Clint,
Colette,
how are you doing?
I'm doing all right. I'm a little stretched, a little thin, but
Yeah.
getting through it. Yeah.
I was watching an hour-long video on window installations, and there is a particular tape sealer that goes around and it's like stretches, and I thought of myself as the guy was doing. It was like a This Old House like YouTube video. Anyways, the guy was stretching it, and I immediately thought, wow, that's like how I feel.
It just keeps stretching. Like,
It's like a metaphor for me. The tape is
yeah,
me.
yeah,
Um,
yeah.
I confess that I have been working, trying to work on a theme song for us for our
A theme
podcast.
song. Oh my God.
Yeah.
Well, you're the person to do it, not
So
me. All I got is my bongos back here.
you should like send me a sample of them and then I can like put them in.
Sure. Yeah. I'll bring you my best amateur bongo. I just
Um,
got these for my birthday. I've always wanted bongo drums, and now I have some, and I might actually take some lessons and learn how to play them.
that's pretty amazing. Soon, before you know it, you're just gonna have like a full drum kit, and it's gonna be a whole thing.
Yeah, I actually have a drum kit, but
Oh,
I'm not allowed to play it. So
oh, bummer.
it's in another room. Yeah, it's loud.
Yeah, they are kind
Yeah,
of loud.
they're electric, so they can be headphoned, but they're no fun that way. They cause too much chaos in the house.
Mm, yeah. Oh, yeah. Oh, zing,
Hey,
zing. You're bringing us in. All right, all right, all right. Talk about the real stuff. Very excited about today's guest.
yes,
We've
big
had this
get.
planned for a little while, and I feel super lucky that we were able to make it happen. Uh, we're gonna talk about chaos engineering today, and we're gonna do it with one of like the OG chaos engineering people. Uh, our guest today is Casey Rosenthal. I have a little bio here, so I'm going to read it. Casey Rosenthal is COO of Trifork Americas, formerly CEO, co-founder of Verica, formerly the engineering manager of the chaos engineering team at Netflix. He wrote the definition of chaos engineering, started the conferences, wrote the canonical book on the subject, etc. He has experience with distributed systems, artificial intelligence, translating novel algorithms and academia into working models, and selling a vision of the possible to clients and colleagues alike. His superpower is transforming misaligned teams into high performance teams. And his personal mission is to help people see that something different, something better is possible. For fun, he models human behavior using personality profiles in Ruby, Erlang, Elixir, and Prolog. Hello. Welcome,
Hi.
Casey.
Thank you so much. It's great to be here.
We are so excited to chat with you today. Uh, how's it going? You have a green screen. Can we put flames on it? Can we put "This is fine" flames on it?
Just edit this in post. Have have
That's
the
the
burning
brilliance of
house.
having a green screen. We can do whatever we want with you now.
I've been
you
thinking.
you won't be the first.
I've been thinking since we're probably going to move in the next few months. I've been thinking about like sort of capture like screen grabbing my basement look so that I can just like put it on the back of my thing even after we move, so that people don't realize that we're not in the same house.
Did I see it lying around, Did you already move and you're just trying to tell us without telling us?
um
Shake your
yeah.
head.
um so Casey, we are so excited to have you here. We're especially excited because you are the expert in chaos engineering among us, certainly among us three, but also kind of among us in the broader sense in the world. You're kind of like the world renowned chaos engineering guy. And we have a question that came in, which is what is the difference between chaos engineering and resilience engineering? And we were hoping that you could help us answer it.
Yeah. So that's a great question to start with. I think my sarcastic answer to this used to be, well, resilience engineering isn't a thing that you can define, but we can give you a really long reading list. And after 20 years or so of reading books about it, then like you'll kind of understand what resilience engineering is.
It's like Zen
But yeah,
Buddhism that
actually,
way.
yeah, I do think that is one of the or it leads to one of the differences, which is that resilience engineering is like this great exploration. Like, you know, we went to the Lund program, and there's like uh, so much cool stuff happening in the field, like in like academically that can be researched. But it's not, it doesn't like circumscribe, it doesn't prescribe an application. So you can't say, oh, I'm going to resilience engineer this system and have a blueprint of what you're going to do, or you know, or compare notes with somebody else who's resilience engineering a system, because it's just there. Yeah, there's no prescription for it. Whereas chaos engineering, like, yeah, I can tell you intro, level 1, level 2, level 3, like, you know, here's how you do it, here's where you start. There's a ton of you know, for lack of a better phrase, best practices in the industry. And yeah, there's even like a book about it, you know,
That you
specifically
wrote.
relating to software. Yeah. um, so yeah, so chaos engineering is like, it's an empirical practice that you can do, and resilience engineering is kind of like a field of study.
Hmm.
Um,
One thing that I think might be similar between the two is that when you present what you're thinking about doing in the resilience engineering or chaos engineering context, it can sound a little crazy to your management.
yeah. So what attracted me to resilience engineering is that there are so many things that you come across when you're trying to make a system more reliable that are counterintuitive. And originally the notion of chaos engineering was also counterintuitive. Like, oh, you want to make the system better? Why would you go
Break
break it?
it.
You know, yeah. You know, Chaos Monkey was like the reference for chaos engineering. Um, and so like that like counterintuitive approach just kind of travels all throughout different areas of resilience engineering. Like, uh, you know, it seems intuitive that if you want to improve your availability, you should start by measuring it. And well, nope. Turns out MTTR is a bunch of crap. I don't know what
Horseshit.
the
It's
yes.
fine.
I was
You can
gonna
say
say I wasn't
horseshit on this.
sure.
Hooey.
Yeah.
You can say horseshit, especially if it's related to MTTR in this podcast.
Yeah.
So.
And you know, and other quantitative methods to measure reliability are also horseshit. Um, and so then that opens, it's like, okay, the thing that's most obvious isn't right. Okay, well then you've got a bunch of interesting angles to look at. Well, then how do you solve the problem? Um, Guardrails. You think, well, okay, you want to make a system safer, put in guardrails. Nope. That doesn't make a complex system safer. Um, Run books. Well, maybe if you just document everything. Nope. Root cause analysis. Well, maybe if you just dig down and find like the one thing that, nope. Uh, all of these things make sense if you don't like actually, you know, study the material. And so it's from my point of view, like that's what makes resilience engineering and chaos engineering really attractive in like a brain tingly way.
I'm
Uh,
curious, like, could you talk a little bit about where chaos engineering came from?
Sure. Yeah. So it was a blog post that Netflix released. Oh, geez, like 15 years, maybe more than 15 years ago now, um, about Chaos Monkey, which was a tool that they wrote that would randomly turn off EC2 instances in AWS. Why on earth would they do that? Well, Netflix was a very special place. They had dozens of small teams working on a microservice architecture, and they didn't really roll up to anybody. So like very flat hierarchy. There was no CTO, there was no chief architect. And when they migrated from data centers to the cloud, they were one of the first companies to like be big on the cloud. Their stability just sucked. They were constantly collapsing, and so they tried dozens of things, but the thing that worked was Chaos Monkey, where it basically took the problem that the company needed to solve, instances are disappearing every day, and put it in front of all of the engineers. So by accelerating that to where every day one of your EC2 instances was just going to randomly disappear, well, now you couldn't get any of your work done unless you solved that problem.
Yeah.
And once you did solve that problem, you didn't really have to think about it again. So yeah, I mean, any other company, you would have had like a chief architect say, prescribe like, okay, here's the way to like get around this thing. And in Netflix's case, because they didn't have that mechanism, this is the thing that provided high alignment in a way that the engineers could act on it.
So I'm like, who came up with that idea?
A lot of people take credit for it. I don't really want to wade into those waters.
Okay. But was it like an engineer, or was it like
it seems to have been a collaborative effort between team leads and engineers.
Okay.
Some people have talked about it more. So I can tell you, at the same shortly after Chaos Monkey came out, they started blogging about the simian army, like an army of what we would today, I guess, call agents that caused chaos. So there was Chaos Gorilla, and so there was like this whole like crew of
Janitor Monkey.
Yeah, Janitor Monkey. So much to my chagrin, when I took over the chaos thing, the simian army never existed. So Janitor Monkey was one of the tools that was actually written. Chaos Gorilla was the tool to shut down AZs. That allegedly worked on somebody's laptop when they were let go from Netflix. So, but people, that didn't stop people from talking about it. So it made it into keynotes, and even like the DevOps handbook talks about Chaos Gorilla, and it's like it was never
actually.
It's never a thing.
I assume this has been revealed before. Otherwise, we may need to do a little more PR
do
for
we
this
have
episode.
Deep dark secrets on this?
Yeah. I mean, I feel like people lose sight of that aspect of it. But for whatever reason, like Simian Army was a notion. It wasn't a practical thing, but Chaos Monkey was. And so fast forward maybe 7 years, I was hired to manage the traffic team. And at the time, the traffic team was like the kitchen sink. People were just like dropping all these projects on this poor team. And so chaos engineering came under my purview, and my boss was like, hey, can you go like do something with that? Like, improve our availability or whatever. And so that's when I looked at, okay, Chaos Monkey's a thing that works. Simian Army is just an idea that never really took off. And so I went around Netflix and asked people, like, what is chaos engineering? And I got a bunch of different answers. And usually what I heard back is, oh, that's when we break stuff in production. And I had just started there. So I was like, I'm pretty sure I could break stuff in production all day, and that would not like lend itself to my longevity working here. So that's not a great answer. And in fact, I went out to a broader circle in like Netflix was all on site in the southern part of Silicon Valley. So I called around Silicon Valley, like, what does chaos engineering mean to you at LinkedIn? And they didn't really, outside of Netflix, they didn't really have a notion of chaos engineering per se, but usually that's what I would get back. Oh, I think that's when you break stuff in production. So I said, okay, that won't suffice. I sat down with my team, and over the course of a month, basically pulled from resilience engineering to come up with an empirical practice that could proactively improve availability. And Lauren Hochstein, who's part of the community, contributed a lot to the ideas that went into the definition. We came up with a definition. It's still at the principlesofchaos.org. It's translated into like a bunch of languages now.
Cool.
And we really just pulled from notions of experimentation to say, okay, here is a process to set up an experiment, and the end result will be you could possibly learn a new thing about your complex system that you didn't know before. And that knowledge is a proactive way to improve your reliability. So like everything else in our field is pretty reactive regarding incident management or reliability. If you think of like, well, incident management itself, like obviously the incident's already happened. Observability, you're looking at stuff that like you're going to get a signal of something that already happened. Yeah, so with chaos engineering, it's and like now there's like continuous verification, a couple other things that are kind of parallel, but really chaos engineering was the first thing that said, okay, we are going to proactively improve reliability in a methodical way.
And does that, I mean, because then there's also like load testing. Like, would you consider load testing to be a kind of chaos engineering?
Like if it's done frequently, then it can be a kind of continuous verification. But there's two things that kind of put it outside. One is that it's testing; it's not experimentation. And the other is well, yeah. Let me talk about that one first. So, like when you're testing a property of something, you already know what the property is, and you're just looking for valence, like it's true or false.
Right.
And the great thing about experimentation, like the reason that like Western medicine is so successful is because it's a process for uncovering new properties of a system that you didn't know about before.
Yeah.
And so like strictly speaking, that creates new knowledge. And in complex systems, like chaos engineering doesn't really apply to simple systems. In complex systems, that's the proactive advantage is like, oh crap, I learned something about the system that I didn't know before, and that may or may not change my behavior as an admin. So load testing tends to be like, I know at some point it's not going to take any more
It's going to
load.
tip. Yeah.
Yeah. And you're just kind of like putting a watermark there, which is great context to have. I'm not saying don't do it. And the other thing is load testing you can do with a simple system. Like it doesn't necessitate a complex system. And in fact, it probably doesn't highlight the things in a complex system that generally would be more interesting from an operator perspective. So like if there is a linear or some like formulaic description of how the system responds to load, okay, that's cool. That's good to know. But chances are, as an operator, you're more interested in like one-off events that are going to look different from load just going up or down. Like
I don't know, Casey. I agree with you on many levels there. That's like how they're designed. Load tests tend to be like we think the curve should look like this, and to me, it doesn't rise to chaos engineering when halfway through you have to shut it all down because something that you didn't know existed starts alerting, right?
Yeah.
Like we definitely this happened in a recent load test where we kind of knew that we didn't know what's between what they're putting in the system and what they're expecting to come out, and they wanted to do all these like in the back rooms synthetic like simulations, and we were like, do it in production, like, which I feel like it's sort of ad hoc chaos engineering, but maybe I'm giving myself too much credit. I was like, no, I kind of want to watch it break. We're going to declare an incident before it happens. We're going to watch it, and we're going to see maybe it goes all in the happy path. It absolutely did not, but we wouldn't know how it was going to break and how that like little subsystem in the middle was going to get challenged because its load curve was completely different than the rest. Everybody else was going up like this, and it was like straight to the roof immediately, and no one knew that. because they just hadn't watched the whole system while users had come in. So I feel like I would expect some chaos engineering is like pulling the plug on things, but some of it is also like just pretend we're having our worst day in a somewhat controlled way. That still is it can controlled chaos engineering be a thing?
Oh, well, the best chaos engineering is always controlled, right? Especially to minimize blast radius, because pissing off your customers is not the point, right? Like every once in a while, I get a question like, should we still run a chaos experiment if we know it will fail? No, that's not going to teach you anything.
Right.
Like if you already know it's going to fail, like fix your shit first, like so one misconception is like the point of chaos engineering is to engineer around chaos. It's not to introduce chaos. Like that's not where the name came from. At least that's not where the name was derived in the definition that we wrote. What you're describing sounds like a chaos experiment because you didn't know what was going to happen. So like it's probably not worthwhile to like pick over the semantics too much in that kind of case. But just think of so usually a chaos experiment around availability, like the by far the most useful treatment to apply is some form of latency. And there's this broader umbrella of empirical things that you can do that provide context to people, called continuous verification. And usually I see load testing most usefully applied within a continuous verification context. So I don't know what kind of system that you were describing or that you're talking about there, but if we take like a generic one like um, Kafka, I guess, or some like stream processor, um, if you're operating that infrastructure, almost everybody operating Kafka right now knows that at some point it's going to fail. But like if it's not failing right now, I don't really know like between here and there, like how much distance I have. So imagine if you had a system that could, um, first of all, detect when Kafka started to sweat. So in Kafka's case, that's like if the tail latency like jumps by an order of magnitude, or a standard deviation, say. So that's something that you could look for, like that precedes Kafka failing, and that way like customers might not notice. And so if you use that as like a detection, you've got your pulse on that, and then you say, okay, now what happens if I increase the number of connections to the brokers, like client connections? Like at some point it's going to start to sweat, and then you can back off and say, okay, there's a high watermark for number of connections. Now let's increase events per second. Again, you get another high watermark, and then like package size and throughput, and like there's all these different dimensions. And imagine like you can kind of like draw a circle around, like, okay, these are the boundaries where your infrastructure, the way it's set up in production, like you described, starts to fail. And as long as you're within those boundaries, you're safe. Like very few operators actually have that kind of mental model and that context. And once they do, usually through tooling, it's really difficult for them to go back to a world where they don't.
Very much so.
Yeah.
I'm also curious because that must change constantly too. Like those.
Hence the continuous part of continuous verification. Yeah. So do that constantly or like every day, and then plot it over time, and then, run some change point detection on that. And you can say like, okay, for the past month, your infrastructure behaved this way. Today, you need to pay attention because it's behaving in a completely different way. One of my favorite, so I collect failure stories, right? Like that's where, uh, uh, the void came from. I was working with Courtney on like, let's get data on failures. And so like one of my favorite failure stories about Kafka in particular, in this case, big retailer used Kafka on their private network, which for a variety of reasons ran like more things that it should. And they did load testing when they launched their services on Kafka, and they figured out like, okay, we've got like over 100% overhead. So given our growth rate, we're going to be fine for, I don't know, 2 years. And like 6 months in, Kafka expired their resources and, ran into the ceiling and fell over. And so they looked back at it, what happened? And what they found was about a month prior to the failure, the ceiling had dramatically been reduced because somebody in a completely different building on a different campus had changed the network segmentation for their part of the operation because they saw it was unused. Like, there's no way that a chief architect or like anybody sitting in a centralized role would bring those people together and say, oh, you two need to pay attention to this potential adverse outcome. Like, it's a perfect it's a perfect unknown. It's a perfect incident, right? Like there's no way that humans or AI could have reasoned their way through that kind of failure. But a continuous verification tool would have
Alerted.
alerted to them
Yeah.
a month prior, hey, something's different. Not necessarily what, I don't know what, but like, then you get a human in to look at it and go like, oh yeah, our load tests don't seem to be relevant anymore. Why is that?
I want to kind of go back to the Chaos Monkey for a second, because the Chaos Monkey deleted EC2 instances, and that caused engineers to behave differently.
Yeah, it's cool.
And what you're talking about when you're talking about experiments, you're talking about learning about systems. You're not always talking about like changing engineering behavior on the ground. Was that part of your experimentation framework for chaos engineering? Do you think that that always should be part of the experimentation framework, or is it enough to just learn about the system?
I I my assumption is that almost all engineers slash operators are um, intentioned and skilled enough to behave differently if they have different information, particularly about an impending outage. Like, if you look at Rasmussen's model, uh, safety economics, uh,
Like basically like health, like personal health, or like there's like the physical limitation of like
yeah,
you will fall over if you work 24 hours a day, 7 days a week. Yeah.
yeah. So if you know that capacity, yeah, if you know that you're about to run out of steam, like, you're going to do something differently. If you know you're going to run out of money, like, nobody has a rule that you're not allowed to spin up 1,000,000 EC2 instances at AWS. We all know that you don't do that. Like, I know I would be fired if I did that, but like, it doesn't have to be explicitly told to me, right? So similarly, if I know that a thing that I'm operating is going to like take down a customer facing thing that's going to cost the company a bunch of money, I'm going to do something differently. Like, I don't have to be told that's bad. So so a lot of chaos engineering relies on the presumption that people will at least understand how to act in the organization's best interest. Whether or not they're empowered to is different. And like, Netflix was certainly a special case in that regard. Um, but yeah, that gets into some of the more interesting aspects of resilience engineering. Like, root cause analysis. Like, why is it ineffective? Because you're at the wrong end of the spectrum. You're trying to change an engineer's behavior instead of the CTO's priorities.
Well, I have a question actually. I'm going to take it back to the Chaos Monkey, because I think Chaos Monkey did actually delete AC2 instances, right? Like, that
Yeah.
wasn't just like a threat. But then it's funny that you mentioned the Simian army never actually really became a thing. But I feel like knowing that it was around changed engineers' behaviors too. Like the Chaos Monkey was like an example. Like, hey, engineer, be ready for this. But do you feel like it invited engineers to think about more failures and like more rugs that will be pulled out from under them? Like, was the threat enough in some
I
cases to change behaviors?
um Yeah, debatable. I mean, again, Netflix was full of a bunch of type A personalities at the time, so a lot of strong opinions. But the reason that Chaos Monkey did the thing in production is because nobody knew, like there wasn't another mechanism to get that information to the engineers, and um, like it didn't make the system any worse than it was. So
Right.
you know,
Things
it
were
was
already failing all the time. So like doing it
exactly.
programmatically wasn't
It was
necessarily
just an
like
intentional
cutting a
version
nine off.
of
Yeah.
it. Yeah.
Yeah. And it did turn everything around in like the span of 2 weeks. And
Hmm.
aside from one like ironic instance since it Netflix hasn't been brought down by an EC2 instance disappearing. So like it worked really well. Now Chaos Kong was a thing, and that was regional failover. And in that case, we had to simulate regional failover because AWS wouldn't let us turn off another region, something about other customers being there or you know, something ridiculous like that. But I'm sure you know, like the regions do actually go down every once in a while. So yeah, so this was inspired by a real world event that lives in Netflix um, history. Their part of their culture, or I don't know if it is now, but it was like Christmas 2012. Netflix went down because US East 1 went down. And that's like the worst time that Netflix could go down because, you know, it's Christmas. Like you don't want to have to talk to your in-laws.
You
Like
got
the
to
reason
stream
you,
that log. Yeah.
yes, the reason you got Netflix was so that you don't have to spend attention on your family, you know? Um, let's say in-laws, right? Like to soften that. But like so, you know, it was really so it had a press impact. And so we spun up this program and we thought like, oh, okay, well, Chaos Monkey worked well at the small scale. Let's try it at the really large scale. And that got a lot of pushback from a lot of teams that weren't involved in the project because they had other priorities, right? Like they're trying to add functionality. And for my team to come in and completely disrupt that to reprioritize them is inconvenient to say the least, which totally makes sense. But it's also probably how a competitive organization should work, where priorities are, you know, preempted by bigger priorities. Um, so in that case, again, it changed behavior. But like if there was it, it's not necessarily that it had to like break something or have a severe consequence. I think really the getting the knowledge of what the impact was probably sufficient to change behavior. But again, we couldn't figure out what would happen if a region went down without actually doing it. So it was kind of the only way for us to get that information. If you can get information like that in a safer way, and you know now there's a bunch of ways to programmatically do that, then I think you should. So yeah, it's not about breaking things. It's really about the how do I systematically discover properties of the system that I didn't understand before, and that's what Chaos Monkey did. It was like, oh, okay, if an instance of that system goes down, then the others compensate by doing this bizarre thing, and that ends up cascading and taking the whole system down. Which any good microservice has lots of cases of that are hidden.
Yeah.
It's what also makes them fun.
It's funny because I had a CTO at one of the first startups where I had a really impactful sysadmin job, and if he wasn't in the office, I would assume he was at the data center, and he would pull cables out of the switch. And he would tell me, it's your job. You're the sysadmin. It's your job. One of these cables may disappear, and I'll put it back in 20 minutes, and We'll see if we had an incident or not. And I always thought about when I saw Chaos Monkey, how much that made me pay attention to when he did it, because I tried to prepare for it, right? But like what you're pointing out was, I was actually thankful. I was like, oh, Nick pulled a cable today. I could tell because I would get an immediate ping monitor, and then I would go look, like what's breaking, you know? And there's some developer like, I'm trying to deploy and I can't deploy right now, right? It was way more useful than trying to imagine it. It was like, okay,
Oh yeah. How
Nick,
would
please
you?
put the cable back. We learned. Like,
Yeah.
we're gonna move on. So I like, it's not unique to Netflix, but I find it's interesting that Netflix, at the scale they were at, because we were certainly not that scale, was doing it, and nobody got terribly mad about it. Sounds like, did people get mad about it? Did anybody
I
get
mean,
mad about it?
for Chaos Kong, people got mad about stuff. For Chaos Monkey, because it was such a short loop, and again because the service was already like, they were rolling out. They were first customer to roll out auto scaling, or they were working in conjunction with AWS to implement auto scaling. So again, the quality of the service, the uptime of the service was already so bad that it was just a net positive. But Chaos Kong was years later, and so that was, yeah, there was, I had to negotiate with a lot of teams around scheduling. So the first few that we did, it was like an all hands on deck, right? Because like this is the whole system that we're affecting here. So it wasn't like the entire engineering org, but it was like the people who would be on call for critical systems be like, okay, we're doing a Chaos Kong exercise. Is everybody, dialed in? And then, after a couple months, we got more comfortable with it, and we're like, okay, we're going to do this every month on this day at this time. And we would notify people, by email. Did that for about a quarter. Then we said, okay, we're going to do it every month during this week. And like, everybody had access to the same observability metrics, so they could tell when it started happening, but like they didn't necessarily have notice. And then, within about a year, we got to the point where like, we're doing these unannounced. And so that trust in the team was earned. Um, and, a lot of the communication out from the team was about the steps that we were taking to make it as safe as possible, and provide as much transparency about what we were doing as possible. But in the first, I don't know, half a year, when we would have the scheduled ones, sometimes we would start failing out a region, and we would get 15 minutes into it and be like, oh, that's not right. Okay, roll it back. And then we get a finding. We take it to the teams that were affected and be like, okay, here's what happened. That can't happen. And then that's where some of the pushback would be like, well, I've got to deliver all these features, and now I have to figure out this thing too. Well, yeah, because sorry, but
We're just giving you advance notice. You have to figure it
because
out. You would have
USC will go
eventually had
down.
to.
yeah, it's gonna happen. So either you fix it now with us, with our help, or it's not
I,
going to be so pleasant the
I
other
have a
way.
mantra I say to management a lot when they're sort of not sure about reliability investments and stuff, and I say, like, the point of doing that work like this is to invest at the time and place of your choosing, right? Like,
Yeah.
you will invest in this, and like, at least this way you get some advanced idea of what will probably be the value of your work. Whereas when you're fully reactive and you're just waiting for those EC2 instances to disappear, like, you may have other things that you've committed to now, and you have to move them. At least with the
And
Chaos Monkey, it's like, okay, we tried it before the consequences came.
I think a lot of engineers confuse those two investments, because one of them is least effort to remediate, which is what everybody gets kicked into during an incident. Like, how do I put the fire out as quickly as possible, which is appropriate, right? But a lot of people confuse that with the I don't know, the resilience work or the reliability work, which is not trying to find the least effort to remediate. It's it's thinking about things. It's possibly implementing a completely different architecture. I don't know, but it's definitely less. It's a very different exercise.
And it's one that's hard to get hard data on. A lot of us have feelings about the system, right? Like, oh, I just know it's not going to survive that, or I'm not sure what the dependencies are. right? That stuff, it has nothing to do with least effort to remediate, but we know it's involved in incidents until they happen. We don't really know how. And I think, if I'm starting to understand what you're talking about, chaos engineering invites us into that space before the reactive incident happens.
Yeah, So I mean, to give you another example, like a lot of people take least effort to remediate and just substitute that for RCA when they write it up. They're like, oh, this line of configuration was applied and everything broke, so we quickly rolled back that line of configuration. So now I'm writing up the RCA. Well, what was the problem? It was that line of configuration, and it's like, well,
Such a nice little math equation, though, isn't it?
right,
Mm-hmm.
right,
Zero
right,
sum.
and
Excellent.
it, yeah. Again, it's like one of those things. It's super intuitive. It's wrong, but but it feels right. Um, and so the more important work is looking at all of the other things. And yeah, I don't know. It's interesting. Availability work and security are two sides of the same coin. System safety, and security gets treated very differently in a lot of ways. And so for me, it's always fun to like look at how security treats proactive work and analysis versus and resource investment. Like if selling security software is like good business. Selling reliability software, not so
Not so
much.
much. Why do you think
Um,
that is?
Honestly, I think this is a fluke. So I'll give you another example in software where there was like a divergence, and I don't think there's any reason. It just had to go down one path, and that is uh, simulation versus uh, uh, what would you even call it? Like I guess empirical observation. So when we do like cloud capacity cost analysis or performance testing, we've got all of the properties of our infrastructure. We could have built a world where we can run um, uh, discrete simulations of our systems and just run like, okay, here's 50 different possibilities of load. Just tell me like what the resources need to be for the components of it. We didn't build that stuff. So instead we just do the empirical observation of like the load testing example earlier, or like we do A/B testing. Um, and it could have, I think software could have gone either of those directions, and we just ended up in the like, no, we'll just try it and then see. And I think security and reliability, actually, I think the SRE book has something to do with this divergence. And I love particularly putting on the book, because then Courtney will feel some responsibility for this. The SRE book made the case that the way to improve reliability is through uh, hiring people. You add like the resources that are adding are people. And security went the other way, right? Like most companies that invest a lot of money in security really understaff their security teams, but they spend a fortune. Gonna watch my language. They spend a lot of money, a ridiculous amount of money on software solutions and security. And hyperscalers, when it comes to uptime, do the opposite. They don't spend money on software. They spend money on headcount. And then like, Google being the epitome of this, where like 10% of their staff was overqualified and bored. So they're like, okay, well, you can, stand over the shoulders of more junior people and call yourself an SRE and tell them how to, build their systems more reliably, which nobody else has been able to repeat in the industry. But yet we still have SRE programs.
Doesn't stop us from calling them SREs, though.
Most SRE programs fail, but yeah, that's but yeah, I mean, so like we're just kind of in this mindset that like that's how you address reliability stuff. You hire more people, and the people do smart things, which as far as I could tell, would equally apply to security or as well. And we just have different patterns for some reason.
I feel like resilience would say you have to have capacity somehow, right? And the tooling or the people aren't necessarily going to be the whole picture, right? Like that's where like reducing it down to I'm going to add a few people and they'll get some reliability work done. That's not necessarily adding the capacity that's needed.
Well, the adaptive capacity of the adaptive capacity of a system is always people, but it's not necessarily like you three, you're the adaptive capacity. That's like not how systems work, right? So you can't just do that.
And it's not new people usually.
Yeah.
Like that's another thing.
It's not people
Like,
who don't know anything about your
in
systems.
fact, new people might actually cost the people who have the
Yeah.
capacity time to get them up to speed, right? Like,
Yeah, I mean, whenever, gosh, the amount of times, if I had $1 for every time somebody was like, we're so underwater here, what we need to do is hire more people. I'm like, absolutely not. That's not what you want to do. But that is always what people want to do, isn't it? Yeah.
In availability, in security, it's, oh, let me talk to some more vendors.
Let me outsource. Well, I do feel like I dipped my toe in cybersecurity briefly as a manager of a team, a couple teams in Norway, and I do think like there's also a lot that like can be outsourced. Like you can pay other people to have this part of your problem, right? It's like at least that was my experience. Was like there are a lot of like there are a lot of elements of things that you pay others to do, whether that's pen testing or, compliance work, or whether it's sort of level 1, like vulnerability screening or something. Like,
So take a minute. Is there any reason why those functions couldn't equally
no,
apply to?
they
Yeah.
totally could be internal. It's just like for whatever reason, there are these vendors, like you said,
Yeah.
and you can outsource like so much of that work. Yeah.
I mean, if anybody wants a business idea, like,
But like also how weird is that though? Because then your teams don't really, your internal cybersecurity teams, like how do they, what are their mental models of the systems versus like, how does that change like your adaptive capacity essentially? I don't know. Interesting question for another podcast. Thanks for coming up with our next podcast question
yeah,
on the
maybe we'll
fly.
be back to talk about how the fortunes spent on security.
Thank you so much for spending time with us today, Casey, and explaining the difference between chaos engineering and resilience engineering. I totally understand. I'm 100% clear. I can write a paper on it for Lund.
That's awesome.
Can't wait to read it.
Yeah, I'm super excited. We'll have to have you back on for some other stuff soon. Thanks. And I hope your question was answered, dear listener. Bye.
Thanks, Casey.
Bye.